All right, today we're going to start on a new concept, and we're going to start on energy. And energy is basically another way to look at motion. It's another way to calculate the way objects move. In principle, energy can come from many different sources. There's energy associated with the heat of a flame. There's energy, electrical energy in the light bulbs in your house. There's solar energy from the sun. There's chemical energy from things like the gasoline in your car. And there's also nuclear or atomic energy from, for example, some power plants. But the kind of energy that we're going to cover in this part of the course is simply the energy that comes from physical motion. In physics, energy is defined as the ability to do work or the ability to transfer heat, but that's for another class. So we need to define what work means in physics. And in physics, work is defined as the integral of F dot dr. In this case, F is the force that's acting on the object, and dr is a infinitesimal step along the direction of that object's motion. For work, the variable is capital W, and the units are called joules, where 1 joule is 1 kilogram meter squared per second squared. And again, just like with newtons, if you stay in SI units, you don't really need to worry about what units joules are. You just know that if you use SI units, you will have joules. Work is not a vector, it's called a scalar. It doesn't have a direction, but it can be positive or negative. Let's look at that integral more carefully. The dot product between f and dr. Well, the dot product of two vectors is equal to their magnitudes multiplied together times cosine of the angle between them. So this integral can also be written as f cosine theta dr, where you would integrate over the initial to the final position. And like I said, theta is the angle between the force and the displacement. So let me just draw you a diagram so you can understand what that means exactly. But if you take an object, and if it's just moving in a straight line, if you apply a force to it at some angle, you take the vector for the force, and you take the vector for the displacement, and figure out the angle between them. Now, this isn't a free body diagram because delta r, the displacement, is not a force. It's just a diagram to help you figure out what the angle theta is.